கம்பெனி ஏன் யூஸ் பண்றாங்க கேஸ்மி இப்ப வந்து யூடியூப் யூடியூப்ல இருந்து அப்லோட் பண்றாங்க சீரிஸ் வீடியோ
Distinguished participants and native speakers and dear friends of science. It's a great honor and pleasure to be here with you at the opening of International Conference Mathematics and Applied Data Science Live. Now I invite you to first observe a moment of silence and then sing the Turkish national anthem. Please stand up. This year, coordinated and they are bringing shared remarkable question exercise and solution. So get the next to the theme of mathematics and parting for other. Welcome. From August 29th to 1, 2025, we conduct both physically attended Sağıroğlu University in Konya and virtually across the globe, building a bridge between disciplines. Our industry share and shape innovative research, taking a wide spectrum from applied and computational mathematics, analysis, data management, artificial intelligence and machine learning, energy management, physical, biological, and financial application. Through these events, we will explore presentations that combine modern mathematical theory with cutting-edge data science techniques, addressing social and scientific relevant challenges with solution-oriented approach. Guided by distinguished experts in the field, we will gain new perspectives and foster meaningful collaborations. I hope this conference will serve as an inspiring platform for learning, networking, and exchanging ideas. Over the next few days, through your presentations, questions, and discussions, we will collectively broaden our scientific horizons. On this occasion, I would like to sincerely thank the organizing committee, our keynote, and invited speakers, the Sağıroğlu University for its warm hosting, and all of you, the participants, for your valuable contributions. Now it's my pleasure to officially declare the opening of International Conference Mathematics and Applied Data Science 25 and wish you a conference filled with discovery, collaborations, and inspirations. Now, I am pleased to invite Professor Dr. Mehmet Yavuz, who has made significant contributions in the field of applied mathematics at Sağıroğlu University to deliver his speech. Please, Professor.
Distinguished guests, esteemed speakers, dear colleagues, students, and participants. It's my great honor and privilege to welcome you all to the first international conference on mathematics and applied data science. This annual conference marks an important milestone, bringing together researchers, scholars, and professionals from around the world to exchange ideas, present their latest findings, and explore the powerful intersections between mathematics and data science. Today, mathematics and data science aren't only academic fields, but also fundamental forces shaping the future of our societies. From artificial intelligence to quantum computing, from biomedical science to energy management, the solutions offered by these disciplines help us address some of humanity's more complex challenges. Therefore, this conference is not merely a scientific gathering, but also a shared vision that illuminates the path toward the future. For this first edition, we are proud to announce that more than 300 submissions were received under 12 special sessions and 260 presentations have been accepted for inclusion in the program. Although this is the very first ICMADS', we are honored to welcome participants from over 35 countries, including Turkey, the USA, France, the UK, Bulgaria, Japan, Iran, and Germany. Such broad international participation once again demonstrates the universality of mathematics and data science, their interdisciplinary strength, and their ability to foster intercultural collaboration. The theme of this conference reflects one of the most exciting developments of our time: how mathematics provides the foundation for data-driven approach that shapes science, technology, and society. With the launch of International Conference on Mathematics and Applied Data Science, our aim is not only to create a scientific forum, but also to build a long-lasting international community where ideas flourish, collaborations begin, and future generations of researchers are inspired. I'm also pleased to inform you that we have established special issue agreements with 17 journals indexed in Web of Science and Scopus, which will publish selected papers presented at the conference. Furthermore, 3 book projects are underway with prestigious publishing houses, including Elsevier, World Scientific, and Necmettin Erbakan University Press. We hope that these opportunities will support researchers in finding suitable venues to publish and share their academic findings. We are deeply grateful to our distinguished keynote speakers and invited lecturers whose contributions will enrich the academic program. We also sincerely thank all authors and presenters who have submitted their valuable work and chosen the conference as a platform to share their research. Special appreciation goes to the organizing and scientific committees for their tireless efforts in making this first edition a reality, and to our partners and supporters who believed in this initiative from the very beginning. Dear colleagues, with these words, I am delighted to officially declare the first international conference on mathematics and applied data science open. I wish you stimulating sessions, fruitful discussions, and a memorable conference experience. Thank you.
We thank Professor Dr. Mehmet for his inspiring talk. Now, I'm pleased to invite Assistant Professor Dr. Fatih Kaleci, Director of Management Erbakan University Press, to deliver his speech. Please, Professor.
First of all, thank you for the speech, Mr. the Chair of Conference, Mr. Professor Dr. Yavuz. He talked about everything and we gonna speak to Turkish. Değerli dostlar, kıymetli protokol, öncelikle hoş geldiniz üniversitemize. Böylesine önemli bir kongrede sizleri ağırlamak, bir arada olmak bizler için çok mutluluk verici. Üniversitemize uzun yıllardır yürütmüş olduğu araştırma ekosistemine yönelik faaliyetler kapsamında artık geldiğimiz nokta itibariyle araştırma ekosistemini geliştirme noktasında büyük veriye ve uygulamalı matematiğe dair çok ciddi atılımlar oldu. Türkiye'de 9 üniversiteden biriyiz. Büyük veri üzerinde çalışmalar yapan, yapay zeka süreçleri yürüten. Geldiğimiz nokta itibariyle bu kongreyi başta Sayın Rektörümüz Profesör Doktor Şeref hocamızın mihmandarlığında ve üst yönetimin bizzat yönlendirdiği sonucunda Mehmet Yavuz hocamın da başkanlığında böyle güzel bir kongre inşallah icra edeceğiz. Uzak diyarlardan gelen tüm katılımcılara ben tekrardan hoş geldiniz diyorum. Bu kongrenin bilim camiasına özellikle matematik ve uygulamalı veri bilimlerinin kesiştiği noktada inovasyon yaratmasını biz arzuluyoruz. Sözlerimde tabii böyle bir organizasyonda işin mutfak tarafında destekleri çok fazla olan ve paylaş olan Konya Büyükşehir Belediye'mize, Sosyal İnovasyon Ajansı'na ve aynı zamanda yayın evi ailemize ve Mehmet Yavuz Hocam ve ekibine çok çok teşekkür ediyorum. Size saygılarına selamlıyorum.
We thank Professor Dr. Fatih Kaleci for his delightful speech. Now, I'm pleased to invite Mr. Güney, Director of the Social Innovation Agency, to deliver his speech. Please, Mr. Güney.
Saygıdeğer Erdem sabahlar. Matematik ve Uygulamalı Veri Bilimi Kongresi'nde açılış konuşması yapmak, özellikle Necmettin Erbakan Üniversitemizin nezaketi, haddimizi bilmemiz lazım. Burada kıymetli öğretim üyeleri var. Belirtmek istediğim tek şey, böyle bir işte paydaş olarak yer almak bizim için mutluluk verici bir iş. Biz inovasyonun ve teknolojinin toplum için kullanılması noktasında çalışan, için birazcık daha teknokrasi noktasında bulunan teknokrat insanlarız. Ama özellikle bu çalışmaları, akademik çalışmaları bizler için pratiklerde çok fazla faydası olacağını belirtmek isterim. Bizleri onurlandıran Necmettin Erbakan Üniversitesi'nde teşekkür ederiz. Biz Büyükşehir Belediye'miz olarak Sosyal İnovasyon Ajansımız, kapsülümüz, Konya Bilim Merkezimiz, özellikle şehrimizde bilim, teknoloji ve inovasyon ekosisteminde bir yerel yönetimden tırnak içinde beklenmeyecek şekilde aslında çalışan ve Sayın Bulgar Vatandaş Büyükşehir Belediye'mizin vizyonuyla aslında gençlerin bilimle, teknolojiyle, inovasyonla buluşmasının yanı sıra özellikle akademik kişiliklere de önem veren bir ekibiz. Bugün burada olmamızın gerekçesi tam da budur. Özellikle bilim ve teknolojinin yerel yönetim çalışmalarında, uygulamalarında daha fazla yer etmesi noktasında bizim akıllı şehir çalışmalarımız, şehrimizde dışarıdan misafirlerimiz varmış, fark etmiştir. Şehrimizdeki dijital uygulamaların aslında gündelik hayata uyum noktasında da dijital çalışmalar yürütür. Ama en önemlisi belki de bir yönetim mekanizması noktasında verinin bilimsel çalışmaların kullanılması için aslında en eksenleri bir ekibiz. Burada da üniversitemizin akademik altyapısı ve yerel yönetimin pratikliğiyle hareket eden bir yapıya sahibiz. İmkanı doğrultusu sizleri Sosyal İnovasyon Ajansı ağırlamaktan, kapsülü birlikte gezmekten mutluluk duyuyoruz. Bizleri hani teknokrat olarak yaşamda devam eden bizleri böyle ilginç bir kongrede ağırladığımız için bizi paylaştığınız kongre başkanlar, kongredeki yönetim üyelerine çok teşekkür ederiz. Bu konularda bizlere biraz acelemiz bağışlayın. Suçu lisan etkisi affola. Çalışmanın sayılara vesile olsun. Bizlerin bu bilginin üretilmesinin yanı sıra bilginin himaye edilmesi noktasında da bir rol olduğunu düşünüyoruz. Bu himaye edilen bilgiyle inşallah topluma, memlekete faydalı, yerli ve milli bir üretimin oluşması için aslında o temel üretimlere bir da olsa bir katkımız olabilirse ne mutlu bize. Sizleri saygıyla selamlıyorum. Kongremiz saygı olsun.
We thank Mr. Güney for his inspiring talk. We will not proceed with plenary lecture one. The title of this lecture is Generating Artificial Intelligence, World and Mathematics. The session chair is Professor Dr. Siyam Mineji, and our distinguished speaker is Professor Dr. Şeref Sağıroğlu. I now hand over the floor to our session chair.
Hello, everyone. Hello, everyone. Hello, everyone. I am so glad and honored to introduce the first plenary speaker of this first session of this international conference on mathematics and applied data science. Professor Şeref, tell me if I don't present very well your name. Thank you. Okay. It's really fantastic and to find such a colleague, distinguished Turkish colleague, and also who were known in so many areas of modern technology, cybersecurity, intelligence, artificial intelligence, data, and many and machine learning, and really I need like 3 hours to discuss something and to introduce him. So let me say some few words. He is first professor in the University of Galatasaray University in Ghana. He has been received his PhD from Galatasaray University in UK, and since then it's exceptional and career with a lot of impressive research in his domain of expertise. More than 400 papers and 3,000 citations and a lot of service of community items, etc., etc. And he also organized many conferences and he wrote 20 books. So I don't know, it's very long. And I am impressed that all of us are proud and the community help us to see more in this area, and it's really impressive to be so excellent and outstanding in this all in these fields. If you don't know me, I'm saying Energy from Paris. So now I give you my microphone to Professor. So let's
Okay, thank you, Chairman. I think you hear me very well. And we don't have another microphone, but I will speak through this microphone. Well, I have been working many topics as our chairman is introduced. Thank you for that. And I have been working in many topics, but mainly data science, what we can say is dealing with data. Actually, we are working, let's make it like this. Okay, we are actually living in such a world. This world is named not AI age. We are actually living in big data age. And we are working with data. And as far as we know that data is our source of science. And also not only for science, for the other fields as well, especially for AI. Why AI came into this side today, reached each end user, just because of that, having too much data, or another way of saying, having all the data of the world, as far as we reach, as far as we have. So this is the maybe output of internet. So we know that we are reaching data in everywhere, and data means that even as announced big data, even we define big data with different perspective. So this different perspective really help us a lot to understand data world. If we understand this word, we can develop many things. We can develop new mathematical theory, we can develop new application, implementation, or product at the end, innovation. So, but when we look at this side, this big data world, having really trillions of opportunity inside now, and also have threats inside. We have to look at the things both sides today, more than ever. So when we look at this, thank you. When we look at this site, we can see that, okay, we can see that this word is covering different perspective. We have to improve our horizon for this more than ever. Many opportunities, but also there are many other issues as well. Okay, when we look at the AI side, mainly understanding this ecosystem is very important. Certainly, data is everywhere now. We are using those data to model, use algorithms, and certainly at the end, using processors to analyze those bench of words data. So understanding this is not only topic of data or not only topic of algorithm, topic of everything now. Because AI now considering society, AI now considering government, AI considering all the world because of the outputs of that. So while we are considering this, there are many models available. You will see how many models are available today. You will be surprised. And certainly requires infrastructure more than ever. You cannot carry this data from your memory stick now. You need data centers to build up to run those issues. So help the end user or give the services to the end user. So applications are important at the end. It really is fantastic work. You are reaching the world from those applications. Fantastic experience you are having. You are asking all the questions and having all the answers from that. And recent achievement tells us that it's more than, in some cases, more than 90% of those applications are successful. So when we look at those ecosystem, data is there. We should understand data more than ever. For example, in Konya, a governor is the one of the #1 smart city in Turkey, and he didn't mention, but I knew that. Well done. Understand the data and how they can use it for the society. This is very important. So big data issue is not only covering is data in text. Data is in every range of variables. It might be in voice, text, code, or maybe picture. So analyzing those, all of them together, it gives different perspective. So the goals are important for those. We know that how these goals are reaching. So having this sort of information and analyzing this, and based on mathematics and how we are handling this is important. How actually the algorithms is mainly today is very simple when we look at the things briefly. How is trying to guess next word, probability theory mainly. How, and when I say Konya is beautiful city, Konya is beautiful city. You know, after Konya, it should be is and beautiful and city. You know, what is the probability of that? Algorithms are trying to understand how from available data. And those available data means that having all bunch of data, not only Konya, around the world. Algorithms try to understand that patterns, not only approach, single approach, trying to understand the meaning of that, what comes after that. What is the meaningful based on theory or based on statistics or based on percentage? The highest one is the next one. So when we consider those inside, there are many issues, as we said. But when we look at the things as a scientific domain, mathematics is behind that as other things. Our common language is maths. So trying to understand the nature, trying to understand all things happening beside us. So when we look at the things, as I said, probability theory, statistics, and also big data analytics, data science, natural language processing, image processing, voice processing, and other signal processing are the behind that. When we look at the basic science, computer science and engineering behind that mainly. But when we consider those issues, AI comes from now different perspective. Now generative AI coming, artificial general intelligence and artificial super intelligence is coming in front in a couple of years. You will see how things are smoothly in some cases changing, but in some cases sharply is changing. You will see it later. So the success of those developing algorithms based on approach, how human think, how human decide, how human connections are memorizing, understanding, or deciding the things clearly. So if we transfer this knowledge into mathematical modeling, we can apply it into computers because available processors and available data. So this sort of algorithms really help us a lot to understand the things. It was 2017, Masmani and his colleague published an article about attention is all you need. If we pay attention to the words and how they can combine for a meaningful way, this is the secret of that. Actually, it's trying to predict next step. Initially, it was text, and next words we were trying to understand. But later on, it came to the voice, it came to the picture, trying to guess or predict next pixel, next signal, next whatever you are saying, next code, etc. So the idea is now enlarged and then being used for different sides of that. So the combination of that today, the success of all AI is those 5 groups of algorithms: generative AI, variation encoders and LSTM, and also recently transformers are based on these developments. What it does mainly, converts data into vectors or matrix formats and analyze those connections or those relations, those understanding or meaning in a mathematical representation direction. So these meanings are kept in the memory, but this is not memorizing the things. It's not like that. Understanding the patterns of those vectors, how correlating each other, how that picture or that sound, that voice or that video are being converted into vectors or matrices, and trying to connect those issues. So those issues really help us a lot to find relations among those patterns. And then we receive those outputs, fascinating outputs I will be mentioning. Okay, let's know the AI world mainly. Those are the top 10 countries based on Stanford University Index. This is important. You know, we mainly focus on China and USA, but the number 5 is important here, United Arab Emirates. They really provide a good large language model for the society. It's called Falcon. It is really important in different parts of the world, providing new and different algorithms for the world. So others, you might see how Western is, you see the contribution. Europe also has, but it is not much compared to others. Again, this is another statistics. Importance of that, not the numbers. Numbers are now very low in these statistics, but the idea is that universities are in front of, universities are back of the industry now. Industry, locomotive of these studies, or these developments, or these innovations, these product, whatever you are saying. Now the numbers are more than universities, and joint studies you might see, and state or governments has got their own large language models. But when we look at the other perspective, 98% are open, and the rest are limited, and 28 of those closed. Closed means that not serving outside. So this is really another way of thinking, another way of serving, another way of ruling the academia, because you are spending trillions of dollars, but this is all things are free. We should consider these points more than ever. This is really, so for the society, developing the societies is fantastic experience. We should consider in different perspective again. You know, you remember OpenAI? It started for the benefit of society, but now it's closed AI. It jumped into that because of the market now. Okay, let's look at what is model. You know, model covering information insight or data insight, mainly. And so far, what we know that if the data is more, the model is more successful. More means that, you know, these models are being trained 6 months, paying millions of dollars for the electricity training with those cloud environment. It really takes more time. And, you know, few statistics I will give you. When you consider Wikipedia is 40 billion token inside. Token means that, Konya is beautiful city, is 4 tokens. You can consider like that. And almost 40 billion tokens inside. When we consider the largest, the encyclopedia is 200 million, billion token. And the largest one is when you consider 500 billion token. It's large encyclopedias, I am telling you. But today, when we consider, it's more than that, but when we consider the TS token, 1.7, 2000, the date, October 2024, 1.76 trillion token inside. It's combining all the information or data around the world. OpenAI, last month, they find about collecting data from underground, paid $100 million fine. So we know that where the data is on the cloud, you receive and you use it for training and doing many things, many unexpected or not desired things as well. So, Gemini or Cloud or Olympus or Next, when we consider today, GPT-5 is available now, you are using more than 50 trillion tokens. And when we look at the Gemini 2.5, is more than 50 trillion tokens inside. And when we consider Cloud 4 is available, more than 50,000 and rest. 50 trillion tokens. What it means, you will understand more about that. So what they do mainly, when we look at the things, this side, one model, a foundation model, mainly process text, process image, process speech, process code, process structured data, process signals, whatever you are having. So if there is data and we are processing those in different perspectives. So how about the answer? Answering all things. If your answer should be voice, your question is voice, you can have the answer voice and text or picture in different or even code. How many of you have written a code? I'm sure all of them you've written. So if I ask you to write a mobile application now, how many of you can do that? No, you should erase that. All of you can do it now. If you speak, if you ask question, is enough. Question means that prompt. If you know how to ask clearly, and you can get the answer. You can be developer now, mobile developer, in a minute now. If you have the knowledge of what is going on behind, it will help you. So, task, many. It might be, in some cases, sentiment analysis, information extraction, image captioning, or object recognition, or code generation, or etc. So the answer, in the left-hand side, there are many here base foundation models. Many. I will give you the numbers later. I said now many, left-hand side. But when we look at right-hand side, many application domains are in front of us. Now, one of the domains for mathematicians is now complex algorithm design, or maybe more analysis. So when we look at this side, there are really father of those models, foundation models. And also some models that are open, like DeepSeek. DeepSeek now is really writing the history of AI again, initial. Why? You know, there is no technology that in the world, in one day, after announcing one algorithm, DeepSeek, what I mean, and the economy is dropped down $1.5 trillion in one day. One company lost $1 trillion in one day, $1.2 trillion. You know, it's the effects of those actually behind was mathematics. Why? They found a simplified model, how they can train that model in a simplified case, and they achieved, and they said instead of paying millions of dollars for training, and they pay $5 million. So the things are down suddenly. So this was good for mathematics or for you. It's a good example, actually. Why you pay attention to mathematics is really a good example for in that point. But DeepSeek was not only examples, but the best examples as far as I can say. So when we look at the large language models, you know, it should be showing the dates, but it directly comes. Anyway, you know, the jumping, the success, the performance is really daily, is amazing. But it means that there is a foundation model war now, because these models provide new facilities. These new facilities reach the end users at them. So these end users have the facility of reaching and giving best services among others. So the idea is that capture all the users. Why? Because if you are leader, you are having all the knowledge of society. It means that all the people are your domain of way, domain of whatever you want to do. Okay, let's look at now the reality is another statistics tells us that this is 2025 statistics of Stanford University, and the number of United States foundation models is 385 mainly. But when we look at the China is 362. It's almost similar, nearby. Look at the arrow, red arrow. You know, there is a platform Hugging Face. The number of models available, open source, 2 million models are available today for your use. You can download your preferences, use it in your research, in your project, in your whatever you are doing. This is really a fantastic platform. You know, when we consider more than 3 months ago, it was 1.6 million, now to more than 2 million. But this is only one platform. There are more platforms like that. This is only more famous one I give to you. Okay, luckily there are other issues. More than 500,000 data sets available. You can use it. Download, do it, exercise it, apply it, and do more innovative research. Okay, this is another issue in AI side, developing simple or simpler algorithms for the AI training. So what it does mainly, reduce the requirement of training, reduce the consumption of electricity, reducing the carbon dioxide issues. So this sort of studies are really very valuable. Behind that, again, mathematics is there. So those are the countries they are focusing on mainly. Certainly, it is not the correct classification, but try you understand more clearly. I distinguish or classify it into three groups. In first one is trying to build up models as much as data are possible in trade use. So this is using CPU, TPU, MPU, QPU, DPU, etc. So this sort of technology is really number one. The number one company is processor company in the world. This is critical issue in that for the an example, OpenAI are using those facilities or the other foundation models I mentioned. GPU is another one. Actually, not another one, is the mainly be focused on. The idea is that using less system requirement. So this is important for other issues. But the last one, Compact AI, India government target is use CPU. CPU means that use this. Even this machine has got GPU today. But you make it simple, use the CPU, sorry. That CPU helps us to train the models or to give services. They tested 17 large language models like DeepSeek, Cohen, or LLama, fine-tune and optimize it, use it in CPU. So this is great development. You know, it's another really contribution to the field. Why? Because we don't need much processors in that sense. So use it in simplest platform or available platforms. So those are the main issue on those perspective. Another one, patent. How many of you have patents is here? Okay, you will have. Pay attention, you can have it. You will see now. Okay, when we look at the patent side, and we understand that China has got the highest number of patents based on generative AI. And 6 times more from USA. USA is number 2, by the way. You can see number 2. Almost 6,200 patents available. But surprising thing, this is the top 20 patent companies they have. You know, it's, most of them from China. The second one, United States, 2 from Japan, 1 from Korea, 1 from Germany. Those are the distribution. But most important things, you know, please look at the top on the right, GAN, LLM, via and diffusion models, auto-aggressive models. You know, generative adversarial networks, one company has almost 100 patents. You know, if you work on some neural networks algorithms, it is not easy to have new patents on those, because new patents means in 2 ways. One is from your methods, the other one is from systems. You can have patents like that, or covering both. So it means that, you know, they are working on generative AI in different perspective and having 100 patents from that. Look at the others. You know, IBM has got also patents more than 100. And others you might see, State Grid, electricity company had more than 129 patents they have. Even Bank of China has got a patent, almost 200 patents. You know, is how they are using AI in different domain, you might see. So in order to have to patent, you have to develop an idea. An idea means that mathematically represent, you have to represent it in a way that you can have that patent. So it's not easy. So most mathematicians are doing that, but they don't know if they can have or they can patent it, their work. From my experience, I'll tell you. The work is growing really very fast and different market. And if it is industry growth and company database or employee growth is really removing fastly. And other issue, they are focusing on different side. What it means that, you know, is R&D is the first colors, different colors represent responsible AI, economy, education, diversity, policy and governance, public opinion, infrastructure. So when we look at the leaders, and that leaders are, you know, equally distribute those attention. So each points are important for developing better systems for the society or for the government or for the country benefits. So this is Turkey representation, how this ranking of those. You might see we are is almost in 50, is 45 and 50 band of developing and contributing in that field. So when we look at the understanding the effects of that, you know, it's affecting universities. Unfortunately, many universities will be closing soon, and they will not have students in a couple of years' time. We will face it if we will transform the university concept into AI perspective. So, states, certainly governments has to pay attention. Companies, the way we are 5 minutes. My goodness. I'm almost half. Okay. Okay. And okay, when we look at the issues, it will affect every part of our issues. And when we look at the opportunities, thousands of opportunities we have. And I'm not going to mention the opportunities, you know, really today you can do many things with the available platforms or available foundation models. And you can be mathematician as well if you are using AI foundation. With the help, without having university, what I mean. Those are the things. This is the good is announced a couple of days ago. Nano banana, keep in mind and do tests. You will see what it does really for the future. But the bunch of risk in front of us. This risk from bias, security, data privacy, environmental harm, existence risk, job and profession losses, etc. So there are many unknown risks as well in this part. You know, it's available. Unfortunately, we are facing this sort of risk as well. Plagiarism is just only asking, produce a new one and publishing as it is being done, unfortunately. And you can hack the systems with the voice command and try to find all the vulnerability of the system in Turkey, you can say the system can find and you can attack by voice, not writing codes as well. Risks are everywhere. When we look at the literature says that studies are behind that vulnerability. Data is vulnerable, model is vulnerable, tuning is vulnerable, output is vulnerable. You know, it's all the mechanism we can check. Prompt, the prompt you have written is vulnerable. So this sort of things we have to consider the risk, how we can manage it. There are many risks as well here, countermeasures. You can look, these are the summary of the literature. You can see 2005 reports, how we can consider. And hallucination is another one. Hallucination means that, you know, it's trying to predict the next one. If the next one is not available in the data, bring the second one, brings hallucination mainly. And this is the privacy violation of those. This is a good story. This is my assistant's cat. And he asked to produce a characterized pictures for the cats. Unfortunately, they put one of them is now is dead. Actually, the cat is dead a month ago. You know, he says he never mentioned about that, but the system knows the cat is dead. You know, this is another concern for them. Shall I stop or continue? A couple of minutes more?
2 minutes.
2 minutes, okay. And those are mathematics. You know, it's turquoise color. You can see it's almost human capability. We can say. Now AI, unfortunately, more than 135 IQ, and accelerating is another issue. Please go and find AI core scientists. Do fantastic task for you if you are developing a good article. And also AlphaFold is another one. The impact of that, more than 200 million protein are developed in a short time. Well, you know, it's developing one protein requires $800 million, and it takes at least 10 years. But now, with the help of AI, it reduced. Now, almost all proteins are produced now, more than 200 million protein. You can have a look also Alpha Involve. You can have a look Alpha Tensor. Those are really helping us to develop better. In biology, there are many issues, but in mathematics, I can say Alpha Proof. You can go and check. Fantastic experience you can find in that. In many different fields, you can have even AI transparency. You can check embedding watermarks to identify content generated through AI. And also some important issue I moved. Okay, let's come to the conclusion and say something. AI is a strategic domain you should consider after that. As a mathematics, you are strategic scientific professor. So please consider this. No math, no AI. You should understand that. Okay. So we should pay attention more than ever to AI to develop better models, to develop better issue. Another issue is that, as I said, the world is changing. Now we should try to learn with AI, from AI, and also learning AI is the main issue. But please do not forget, learning without AI should continue as well. We are not focusing on only those issues. And also be ready for the future. Use those facilities to fasten your research, your capability, your skill, etc. And also emerging mathematical fields should be graph theory, mainly what I've seen, and also topology for better embeddings, and also AI alignment for category theory. And this is the last picture, last words. Thank you,
Thanks.
Chairman. Okay, now we are ready for the questions. No, what is questions? No questions. It's up to you.
Thank you so. Okay. Thank you so much for this outstanding talk, and really very important to us because we are lost in this, we are pushing in this ecosystem, AI and all this tool, wireless decision, and we don't know. So thank you for this report or review and your expertise and your advice is very important to us. Any question from the audience? We have a lot of questions, but maybe. And
Thank you. My voice is enough. Yes.
Sure.
I like this word. It's really a good one. The second one, no method of AI. And third question is, what do you think? AI holds some good job, losing the job of different area. What about mathematics? That will use the job.
Okay, let's answer for the last question. Yes, I think the answer is yes. Why? If you are not a good mathematician, you are lost. So you have to be the best, not the good, better mathematician. Yeah.
You know, when you roll your hand,
Yeah.
it's understanding.
Yeah.
Otherwise,
I'm sorry. Sorry.
we tested.
Yeah, yes.
We tested.
And coming to the other questions, yes, the jobs, many jobs will be lost. But if we convert with technology and we are safe, as a professor, it was 2022, November, it was almost, and I got from the social media. My professorship is finished today. So unfortunately, is that. But now today, oh, fantastic experience it was. I don't know many things and AI is telling me. Can being a professor really hard task now. We have been working hard. I don't know how we are going to work harder now. But I know if you have overcome, learning the AI, it really gives fantastic skill for us, for the students, for the society.
If it's a match, the question also any other question. Okay, I think that so let's take the speaker again.
We would like to thank Professor Dr. Şeref for an enlightening presentation and Professor Dr. Siyam Mineci for chairing the session. Professor Dr. Siyam Mineci to present a plaque of appreciation to our distinguished speaker, Professor Dr. Şeref Sağıroğlu.
Thanks so much. Yes, thank you so much. This okay.
We can have it while we are having coffee.
No.
Yeah?
Yeah.
No? Oh, thank you. Thank you so much. Oh, like it. Oh, sorry. Sorry. Oh.
We will now proceed with plenary lecture 2. The title of this lecture is Modeling Real Behaviors with Artificial Intelligence. The session chair is Professor Dr. Yeliz Karaca and our distinguished speaker is Professor Dr. Murat Sarı. I now hand over the floor our session chair.
Bağlanmıyoruz mu?
Bilgisayarı bağlamaya çalışıyorum.
Harika. Ben şununla şey yapsam olur mu? Yok.
Olur bir şey. Ama bilgisayara
Şey yok mu? Mikrofonu var mı? Yapma.
elmas açacağım.
I kindly welcome you to the plenary session 2 at ICMA DST 25, where Professor Murat Sarı is going to be delivered speaker. If I am going to introduce myself, I am Yeliz Karaca from University of Massachusetts, Department of Mathematics and Department of Neurology. As for the brief biography of Professor Murat Sarı, he is an academic of biological, mathematical engineering, specialized in artificial intelligence modeling, numerical methods, and simulation of nonlinear systems. His PhD is from University of South Wales, UK. Dissertation written on seismic wave modeling using the boundary element method. Professor Sarı is currently professor at Istanbul Technical University. He is author of over 100 peer-reviewed publications in top-tier journals and having supervised numerous graduate theses in applied mathematics, computational modeling, and biological systems. So it is a pleasure for us to welcome Professor Murat Sarı, so that he will deliver his plenary speech entitled Modeling Real Behaviors with Artificial Intelligence. The floor is yours, Professor Sarı. You may start if you are ready, please.
Thank you. Thank you very much. Actually, it is not easy to talk after such a nice one. There is a kind of word or jokes, Turkish. There are two close friends, and both of them likes onion very much, and they are having a deep conversation among them, and then one of them says to the another, "If you are the richest one in the world, what will you do?" He says, "I will buy all onions in the world and eat them." And then asking the other one, the first one, "If you are the richest one, what will you do?" And the second one says, so after Şeref Hoca saw, my friend Şeref saw, so I thought that what will I say? But when I checked in the previous slides, he included some, not some, many things, and many people in the scientific domain. I think he forgot to include me. If he included me to the scientific domain, I was going to give up to deliver this speech. So thank you very much. Therefore, he saw after Şeref Hoca explained to reconsider in my mind some, but first of all, I'd like to start by thanking the organizing committee and on behalf of organizing committee, Professor Mehmet Yavuz and the authority of the Hizmet Erbakan University, and particularly I didn't get attention from the local authority. They are very, I do thank them for their very valuable insights here about this about this conference here. So also when I check here, I think we got the 35%, am I right? So I try to focus on, I try to keep on my time, otherwise some of our friends we believe in it, okay? Mathematics and applied science, applied data science, actually, which is not ordinary selection, I think. Mathematics, Şeref Hocam's last word actually, borrowed from Galileo, I think. But I am using mathematics language of science for a long time, for many decades. Now I am updating myself language of universe. Because in one sense, mathematics is science itself. In another way, it's language of universe and therefore language of science. And data science or applied data science, of course, one of the magic word is data. So of course, I don't need to speak much. And Professor Şeref Sağıroğlu mentioned a lot. But of course, it is very important. It is, I believe, that magical word. So of course, before starting our talk, I should, of course, I big thank to authority of Metropolitan University, and I should also myself, and I also all of us must commemorate Professor Metropolitan. He is graduated from my university, and also he was Prime Minister of Turkey one time. So I think I give myself a commemoration with its music. And then now we are going to talk about journey. Yes, I wanted to start journey. Yeah, from nouns to unknowns. Okay, from nouns things to unknowns. If we use the noun things properly, we can manage, we can have idea, we can have some prediction about the unknowns. For instance, if I say I will come from Istanbul to Konya, and usually we don't expect anyone to predict what will I do here. If I say I will come to Konya to Metropolitan University, and of course you have some clues, yeah. You can make some predictions whether it is correct or not. And if you have some, for instance, more information, more data about my travel from the point, you will face, or we will make more accurate, more prediction, fidelity prediction, I can say. Right? So therefore, this is important. I can starting from known things to be able to arrive at unknown things. Okay, so let's go to another slide, please. Yeah. Okay. Yeah. Yes. Little outline of my talk, ladies and gentlemen. What kind of reasons send us to talk or to make this speech? Because when especially my academic experience, sent me to focus on predicting physical processes remains a core challenge in science. One is that one. Another one is conventional computational approach are very expensive and very limited, especially in this age. And another point, very much detailed, Professor Sağıroğlu mentioned, AI provides robust, scalable, and data-driven alternatives comparison to traditional ones. And after these motivation points, I try to take out I try to teach out some research questions here. Can AI models capture, for instance, street behavior still and nominal behavior, for instance. Why I say so? Because stiffness and nominality makes makes the environment, makes the physical system more realistic. So therefore, this is going to be important question, I think. And the second question related to the first one, in some sense, how when do AI surveys approximate real processes? And finally, what are the implications for computational science paradigms? Yes. Therefore, after these questions, actually these questions are encouraged me to say that for my objective is to explore strategies for modeling realistic processes, realistic behaviors, and capturing its the dynamics and examines the behavior of AI-driven models in this sense. Of course, when I say, especially, I prefer to use this word as realistic behavior because in mathematical sense or in applied sciences, many people, some people, I don't say many, some people are working different problems. But when you ask your problems or your solutions are representing what? And the answer you take or you got from them nothing because in the physical sense may not have any physical meaning. So that's why I prefer to say realistic behavior, this reason. And another one, the realisticity is related to nominality, for instance, I will mention stochasticity and so on. When we are in this life, of course, especially dynamic life, pass away, the other way around, get to the other side. Of course, as human beings, of course, not only scientific people, we face problems. Of course, these problems come out as scientific problems, because it is either forensic problems, engineering problems, medical problems, economical problems. I said on the forensic because a couple of months ago I was invited to a conference organized for forensic science. That's the Bangalore program. Okay, so realistic or forensic problems is challenging. In what sense? Whatever they are, it's challenging because it may not be easier to capture the behavior represented by the physical processes, by the physical models, by the realistic models. And then, of course, this one can be checked by using cost, whether it is economic or not, and the capturing is effective or not. Of course, there are lots of ways to do that one. So, of course, we can focus on to discover or to capture the behavior, realistic behavior, which is represented by the physical processes. When I say physical processes, I don't want anyone to misunderstand. I don't mean only physical phenomenon. When I say physical, as our body is part of physics, physical world, I mean, okay? Physical system, or metaphysical also possible. Nowadays, people are discussing about this issue. Okay? Yes. Then we are saying, of course, let me make a bit clearer the realistic behavior. As I mentioned, hierarchical background. What do I mean by saying realistic behavior, or in other sense, intricate? Realisticity invites intricacity or complexity in the physical processes, physical systems. For instance, in my publications, in my works, I can say that, for instance, so was aware of that nonlinear advection diffusion reaction systems or advection dispersion reaction systems and nonlinear dynamics and so on. Of course, in this type of problems, we face as scientific point of view, nonlinearity, stochasticity. Professor Sağıroğlu is very familiar with the stochasticity because of his, of course, the exceptional distinguished publications. And dimensional real world, I want to spend a couple of words about this one. For instance, usually, especially medical people, are spending huge energy for capturing the behavior of the physical systems, either in PDs or ODs, because of the dimension. Usually, especially if you are PDs, you are strongly running from 3Ds or 2Ds. Rarely do this possible because of the limitations of the numerical methods you use, for instance, or because of the domain constraints and so on, like finite difference methods and so on. So dimension of the real world, real system you consider is important, is in other words, going to increase the complexity of the domain you consider, and therefore it's going to increase reality of your process, reality of your environment. And traditional or conventional methods, ladies and gentlemen, especially PDA solvers, either continuous solvers or discrete solvers and so on, are very expensive, especially in terms of stabilization, as mostly all of us experience that one. And AI-based approach, when you come to AI-based approach, like we are trying to use in our works nowadays, deep neural networks or artificial neural networks, surrogate modeling, machine learning, and so on. But we should forget that all of those methods, hundreds of methods, different versions of methods, under one umbrella, which is AI. Okay, we shouldn't misunderstand each other. Of course, I prefer to say AI-based approach because later on we can have an opportunity to mention about it. Yes, different combinations, different hybrid approach can be possible for them. Okay? Behaviors, yes. In daily life, everybody knows this for behavior, yes. When we say behavior here, it's a response. Is a response to an event or change taking place in ecosystem, in physical system, physical environment, okay? Or metaphysical environment, if you like, okay? And various behaviors, for instance, when you mention about behavior of a physical system, physical phenomena, of course, we cannot run away to consider a model. Yes, if you ask, everyone knows really modeling, but when you come to reality, of course, it is important to put the right words in the right places. And a model is quite simplified here, simplified version of reality that is going to allow us and observe and understand not enough and make predictions about the behavior of the physical environment, because when you make little changes, what kind of reaction will take place? Okay, and the models turn real world complexity into clarity. How? By focusing on the essentials. Their design models, in that sense, I can say, reveal deep insights, very intricate insights into the scientific problems. And the realistic models or realistic behaviors usually comes out in two categories, either theoretical or empirical sense. Modeling, of course, as I said, everybody knows, but as I mentioned, a representation of physical process or system, which is going to design to increase appreciation and understanding of the corresponding system. Yeah, I say modeling because without mathematics, as implied by Şeref, Sağıroğlu, without mathematics, you cannot mention modeling in that sense. So sometimes the mathematical modeling, when you say, it seems to me that mathematical is excessive for here. So that's why I say so. Modeling is the essential formalism of science, and or you can say, if you like, language of universe. I prefer to say that one. So a modeling comparison to the scientific point of view is, of course, much more economical and realistic comparison to experimental studies. If you are doing experiments and so on, especially in physics, chemistry, I mean, essential sciences or fundamental sciences, you know how it is going to cost you. So, by the way, I think we shouldn't forget that after 80s, 1980s, even though it is not very common in mathematics, some people are doing experimental work as well. So I think it is a good idea to remind that one. So behavior is mathematical sense. If you ask me to define, I will say a relation between cause and effect relation, which all of us knows, even from maybe elementary or high school, is going to call function. If you ask a social science here among us, they will say it is history. Or yes, we say function. And if you ask me in engineering or AI point of view, it's going to be, yes, X is input or inputs, F is function or processor, Y is output. Because some of us, some of our friends among us may not be aware of, maybe first time listening to these kind of talks. That's why I prefer to say here. So scientifically, we got two types of problems. Why I am trying to underline this point here? Because if we are about to start to do PhD or master and so on, or at the beginning of academic life, it's better to determine our coordinates where we are, what kind of methods, what kind of problems we should use. Yeah, this is important, I believe that. Therefore, if you are trying to reach from model parameters to data, so one day, if you are trying to reach out model parameters from the data, it's the another way around. Okay, so one is forward problem, the another one is inverse problem, of course. I said data at the beginning of my talk, data is much more here. Big data, what's big data? Of course, we know what we mean by saying big data, but it is another important issue. We may discuss about it. Yeah, how much bigger data should be used to produce an academic outcome? Yeah, what is the limitation for that one? In other words, the bigger data, the greater knowledge. Is that the answer? Of course, provoking my expression, my friend, my great friend, distinguished friend, Şeref Sağıroğlu. Yeah, this is important because, yes, this is very important data, but we should be aware of what is the relation, if you are starting from here, what is the relation between data, information, and knowledge. If you are lucky, like Dalai Lama, or a spiritual person, or of course, in the other way around, or scholar, I can say, yes, maybe wisdom and so on. You can go up there on the clouds and so on, okay? So this is another issue, but what I am telling you here, we should be aware of data, information, and knowledge, at least basic ground, okay? So I try to make a little story here for us for all things, either inverse or forward problems. If you start pointer. Yes, if you start from model parameters to try to reach data, you know what it means here, of course. This is forward, and if you start to reach from data to model parameters, is another way around, okay? So, okay, you try to determine your coordinates or already determined, and we are trying to understand when you go back to 1960s. Yes, if you are trying to solve a problem by using a numerical method, maybe two frequency where you using the world, for instance, Franklin's or Shell's papers where you can reach finite element boundary, for instance, finite elements. Yes, you can use only a couple of words because the advent of computers was not very common. Yeah, that time, continuous methods, yes, exact methods, great methods, and guarantee to make you reaching to the heaven, that's okay, but very simple models. Yes, and discrete methods or numerical methods, right? And then more complex models, but still limited. And simulation techniques, of course, some people are citing from here, especially in 1940s, becoming very common. And now our main topic, artificial intelligence. When I started to talk in 2004 in a conference of physiotherapists, and they were laughing at me this morning in breakfast. I mentioned to my friends, yes, they were laughing at me. What are you doing or what are you talking about? Now everybody is baptizing artificial intelligence all over the world, not only in Turkey or in Korea. Okay, why? Because more flexible and more contemporary and of course less expensive. Yes, I borrowed the internet this photo. That's not nice photo, but very nice experience. In my opinion, status of AI development. They are starting from raw data, mesh data, data, yes. And data preparation, algorithm selection training, model training, and model evaluation, and reaching out to heaven paradise. Okay. I try to share now a bunch of thoughts from my experience, from my works here. Only, of course, trying to keep myself modest here from my work. AI modeling from framework. Yes, what we are saying here is, let me take, yes, mainly 4 stages here. Yes, yes, categorizing or stepwise methods, stepwise cases here. Step 1, 2, 3, yes, data and training AI models and validate against physical models with realistic behaviors and scaling realistic and non-linear scenarios. Okay, so and the data connection, feature extraction. Yeah, of course, if you include every feature of Professor Hüseyin Merdan, of course, no need to see it. Everybody can recognize it wherever he is. But in the limited amount of his features, if we can recognize him, this is important. Okay, so yeah, not working forward. Yes, and some case studies from my work. Yes, I did, for not all, but some of them I want to share with you. Relatively new ones. Yes, epidemiological modeling, deep learning, surrogate modeling, which is important, especially your problem, your simulations are not easier to handle with that. So you need to, of course, apply for survey modeling. And we did agricultural forecasting with some of my colleagues from economics, and commodity price prediction we did in last year, a couple of months ago, published. We inspired from the Russia and Ukraine conflict, and of course, the grain provider and food security reasons we focused on, and we produced this one for as a prediction, of course, for future. And environmental pollution, which is, I believe, that's very important problem of the human beings, not only the Europe or Antarctica, everywhere. So this is also another two works we did, of course. And from the last one, attraction, diffusion, action, sleep behavior is very important. This not only going to be, is also important because it's important in fluid dynamics, is important in robot mechanics, is important in nearly every sense. When you look at the nature, you can see everything here. So this is one of a typical example, sleep behavior, one of our publication with my PhD student and previous PhD students also. We published somewhere here, just yes, a couple of months ago published. And you know that the numerical method may not be easier to capture this behavior, but of course I don't say that you can only capture this behavior with AI methods. In some sense, AI methods needs to be, you know, supported by AI, apart from AI methods, numerical methods, and so on. So we need to be careful. AI method is not everything, but is that one of the most important things. Okay, so this is important here. And another one is, yes, this one is, by the way, let me give you an example. Yeah, since, yeah, as you can see, migration, dispersion, and action model, which is very important. Analytical solution you cannot find for that one. So analytically, you can also in now in the literature, but maybe in the future, I don't know. Therefore, we try to produce some solutions for that one. And another model, nonlinear attraction, diffusion, equation here, ladies and gentlemen. Of course, I can share here. Give me 1 second. Give me that one. Not that one. Nope. Yes. See? Okay. Yes. For instance, this one is, of course, yeah, in numerical methods, most of the numerical methods will fail. Even, for instance, some particular values of parameters, analytical methods also diverging. Okay, so this one is published. Yeah, yes, just a couple 2 months ago, I think, published this one, and now we are going back to closed. Oh, good grief. Now, okay. Yes, here we are. Of course, I cannot give too many examples if I want, because the time is limited. By the way, how many minutes are left? Points, okay. I'm trying to reach out there. Yes, then we look at our works. I think this one is the point we need to see here is, yes, AI models capture speed and nonlinearity. See how work and comparisons, AI and numerical solvers accuracy and efficiency sense, and the graphs that just illustrate all the outcomes. And if you notice clearly that AI accuracy, not every sense, be careful, we should be careful here. AI is accurate, but it is only accuracy. And this is definitely AI is faster than PDE solvers. Definitely, this is important to remember all the time. And some more non-linear systems here. Yes, we published yes about 15 years ago on biomechanical problems with our colleagues here. So to leverage to model the events of here anthropometric determinants on tibial kinematics, yes. And the second one is going to be this second what is going to mention. This mentioned is not going to is mentioned locally by using two different AI systems or approach, I can say. The last one published relatively new one is machine learning approach for predicting fault change values using HIV-1. Okay. And also there is another book from the literature again, the artificial intelligence used for forensic medicine. So challenges and limitations for our work, ladies and gentlemen, is going to be important here. What direction we are going to go? Yeah, generalization, and also my friend Sağıroğlu mentioned. Yes, generalization across the domains and systems are very important, especially when you consider the solvers' limitations. Data requirements for rare and integrate behaviors, which are hugely important, and interpretability of models. Yes, ethics, data needs, and as I mentioned, the collaboration among the solvers, of course, and our future direction, as I tried to underline at the beginning, is hybrid physics, AI frameworks, scalability to multi-scale biomedical systems, and ethics and reliability in real-world mechanisms. Anymore, when you come to, yes, we try to add the droplet, not the droplet from the ocean here. I try to share with you a droplet in the ocean. And we consider other realistic models, of course, having a dream. What kind of dream? Everything is starting by dreaming. Like 1963, 28 August, Martin Luther King say, I have a dream. Famous speech, maybe you know from the history. And of course, if you have a dream, you can go on your way. Okay. Reality, yes. Şeref hocam actually a lot about AI, how nice, how holy, and so on, to be able to reach to the paradise from shortcut. Yes, but a couple of months ago, these two guys, yes, showed that one they already reached out the paradise by taking the Nobel Prize in Physics. By, if you understand, with artificial neural networks, it works, of course, it's not a joke. Yeah, even though 25 years ago, my colleagues was laughing at me, now I am laughing at them. Okay, not only physics, in chemistry, yes, in the artificial intelligence to predict protein structure. Yes, they also got same year from chemistry, Nobel Prize, and conclusion, happy end for everyone. Just there, AI delivers accurate, scalable, and efficient alternative to conventional approach guys and represents a paradigm shift, especially now last decade, I can say, data-driven computational science, and strong foundation for next generation modeling approach. Yes, here we are. Yes, any question? Most welcome.
These professors student was where the ideas predicting of the behavior of processes as a fundamental challenge in different scientific disciplines. The work presented aims to upgrade and improve the AI methodologies to develop predictive models that closely make real-world process dynamics, even in highly complex scenarios. The work intends to contribute to evolving changes and shifts computational science towards data-driven solutions. We can now welcome some questions to Professor Şeref, please.
Either everybody understood better than me, or
Yes, please.
nobody understood anything.
Okay. May I ask one question?
Yes, please.
Okay. What could be some specific quantitative metric or criteria for evaluating the accuracy and transparency of AI-generated simulations based on real behaviors, particularly when the data are scarce or subjective or biased?
And of course, this one is going to be, I will answer this question like a politician. Yes, of course, there are some metrics to, if I understood you perfectly, some metrics, of course, are used to assess the accuracy of the AI approach, yes, in the literature. And of course, many more discussions, heavy discussions are going on. And of course, if you are, I didn't mention at all, also Professor Sağıroğlu didn't mention because I don't know why, but the methods we mentioned only mostly based on traditional AI methods. Nowadays, last couple of years, another type of learning is coming in the literature, so which is more effective. They are, the method is using function space rather than traditional sets and so on. Okay, so this is another issue. Is in other words, that tell you discussions are way more. Yeah, thank you very much.
Another question about explainable AIs. Yes.
Yes.
Which are capable of predicting behaviors besides providing interpretable explanations into reasoning behind their prediction. How can your model or scheme be interested for explainable AI systems?
Well, as I said, if you notice, I for the final slides that I mentioned, yes, generally speaking, again, if your AI methods don't work for predicting or capturing behavior of physical or realistic behavior, you can call your neighbors to help you. The neighbors are either numerical methods or another continuous methods and so on, or among your neighbors, I mean, another type of maybe AI methods, generally speaking. Very nice question, by the way. Thank you very much.
Thank you for your interesting presentation, for your answers you have provided us with. Now, dear participants, our session is over. We thank Professor Şeref and all participants for their inputs and for their attention. Now, we can
We would like to thank Professor Dr. Nasser for an enlightening presentation and Professor Dr. Yiğit for chairing the session. Professor Dr. Yiğit's pleasure to present a plaque of appreciation to our distinguished speaker, Professor Dr. Nasser.
Thank you.
Dear participants, we will now have a short coffee break. Our coffee break in seconds. For the break will last 15 minutes, after which our program will continue with several sessions. Several sessions will take place in different halls and online, and you are welcome to join.
Öne son için buraya mı yüklüyorsunuz? Öne sonu konuşmalar için.
Yeliz Karayel konuşmamız aslında. Yeliz Karayel hocamız. Bir de şeyler. Siz biraz tutacağım hocam. Siz biraz tutacağım. Müsaadenizle.
Böyle arasında yükleyebiliriz. Nasıl istiyorsun?
Şimdi 5 dakika
Halledelim.
kapatacağım.
Numara aldın mı?
Aldım.